So we talked about relations. We talked about functions. We talked about domain and range of relations and functions. Okay? We've talked about linear relations. Now what we're going to do, just to wrap up, there's really nothing new in here. It's just taking everything you know previously. We're going to talk about linear functions, which are relations that form lines in which no domain value repeats. Okay, so the best way to start this, let's look at an example. So here we have a situation where we've got time versus temperature. First question, and you see the graph of this, is this relation a function? Do you remember how to test a graph? Yes, it is. I see some people nodding. If you can draw a vertical line and only hit one point all the time, it's a function. As soon as you hit more than 1 point, it's not a function. So we can just, and remember the reasoning why I said, why you explain something as a function or not, domain values never repeat. So you would simply say yes, because domain values never repeat. So if I look at the domain value 0 on the graph, it's got one range value, -5. If I look at the domain 8, it's got one range value, +5. And that's for every single point. So because it's a function, we can say, and this is how we usually describe linear functions, as temperature, the dependent variable, as a function of time. That's how we usually describe linear functions, any function. So it's always the dependent variable as a function of the independent, because the dependent depends on the independent. This is nothing new, domain and range. What would the domain of this function be? Remember, it's a line segment, so we got to use interval notation. From what to what? Remember, furthest left to furthest right. Come on, somebody? Is this a point to the furthest left? What's its x value? No, it's x value. 0. This is the point to the furthest right. What's its x value? 12. So it goes all the way from 0 to 12. Remember what I said, write interval notation first, okay? And you can write it using set notation as well. It would go from 0 to 12, the less than or equal signs. Normally we would put x, but we're in an actual situation here. X has been replaced by what? Not h. Look at the axes. Look at the letters at the end of the axis, little t. What would the range be? Well, here's the lowest point. What's its y value? Not -1. Look at the scale. -5. This one would be 10. So we're going all the way from -5 to 10. Or -5, 10, less than or equal to, less than or equal to, and instead of y, it's called capital T. Is this a linear function? Yes. Because even though it's not a line, it's a segment. It forms a line. Because it forms a line. The rate of change, remember, the rate of change, and I'll just put RC. It's the same as the slope. Second y minus first y over second x minus first x. So we just need a couple of points on the graph. Well, I've got 4 points I can plainly see, so let's use these ones. What point is this? What coordinate is this? Yeah. And this one? Yeah. Yeah. And it doesn't matter which one is you use, the first x and y and the second x and y. I always use the one to the right or higher. So I'm going to go 0, subtract -5. Okay. 0, subtract -5, which becomes +5, over, oh, there's these things. 4 minus 0. That gives me 5 over 4. Remember, we're in an actual situation here, so it's good to convert to decimal. This would get you 1.25. And what are the units? Remember how you express units as a rate? It's always dependent variable per one independent variable. So the dependent variable is temperature, degrees Celsius, per 1 hour. So it would be degrees Celsius per hour. And what does it mean? It means that the temperature increases 1.25 degrees Celsius every hour. That's the meaning of it. One property we're going to add, or properties, but we've seen it before. Is the horizontal intercept or the vertical intercept and the vertical intercept. Well, remember, the horizontal is the same as the x-intercept. It's horizontal, then x-axis. Vertical, then y-axis, so which means it's y-intercept. And what does it represent? It's the x value where our line touches the x-axis. And this would be the y value, where our line touches the y-axis. So if you go back and look at the graph, previous page. Remember, the intercepts are not the point. It's not made up of two numbers. It's just one number. So the horizontal intercept of this one would be the x value where our graph touches the x-axis. Here's the x-axis. Here's where it touches. The x-intercept or horizontal intercept is 4. For the vertical intercept, here's our y-axis. Here's where it touches. The y value here is -5. So those two values would be our intercepts. So the horizontal intercept is 4. The vertical intercept is -5. Okay. Let's look at a few examples. And finish sort of with one example that kind of wraps up a lot of what we've done in this unit. But so do these questions. So here we have a situation, we've got the volume of gas in a scooter. What's happening in the graph? Like what's happening? You guys should be able to, yeah. Yeah, the amount of gas is going down, so somebody must be traveling on this scooter, right? And looks like it takes them 200 kilometers to get to empty, because the volume would be 0. So the first thing we are asked is to write the coordinates of the point where the graphs intersect the axes, and then from there, find the horizontal and vertical intercepts. Okay? So the horizontal, what's the coordinate where our graph touches the horizontal coordinate, or the x? 200 comma, remember the coordinate. Right, so we would say the coordinate is 200 comma 0, but the intercept is just 200. What's the coordinate where it intersects the vertical axis? What point is that? Sorry? 8 comma 0? Or what? 0 comma 8. So therefore the vertical intercept will be just 8. Okay. You guys should be able to do number B, or letter B. Find the domain and range. See if you can write it in both notations, interval, and then convert it to set. Anybody got the domain? Anybody want to take a shot? What's the x coordinate to the furthest left? What x coordinate is here? 0. What about to the furthest right? 200. So 0 to 200. And notice I put brackets because I include both. If we write it in sec, two numbers, the less than or equal to, and then the variable that's being used for x in this question, which is little d. I didn't take a shot at the range. Lowest point, well, it's these two again. This is the lowest point. What's its y value? 0. What's the y value of this one? 8. So it's everything from 0 to 8. Or I would go 0, 8, less than or equal to, less than or equal to, and the variable I'm using for y is capital B. The rate of change, pick two coordinates, find the slope, and then put the proper units. Well, might as well use the 2 points we've been doing here. So this is 0, 8. This is 200, 0. It doesn't matter which one you use first and second, just don't mix them up. So I'm going to go 0 minus 8 over 200 minus 0. Zero minus 8 over 200 minus 0, that's going to give me a negative value, which makes sense actually, because remember we talked, if a line is climbing, its slope is positive. If a line's going down, its slope or rate of change is negative. Let's convert that to decimal. And I get negative 0.04. What are the units? Come on, help me out here. Liters per kilometer. Good. Yep. Okay, next example. Don't get freaked out by this. F of x is the same as what? Y. So just think that you're graphing y equals negative 2x plus 6. And we've been doing those to death. Get the y-intercept, get the slope, graph away. So the y-intercept is 6. The slope is negative 2 over 1. And you should be able to plot the y-intercept, use the slope to plot a second point, draw your line. And that's it. All this means is that it's a function. It's still the same as y equals negative 2x plus 6. So plot 6. And then from 6, it tells me to go down 2 and to the right 1, which means my graph is going to look like that. Here. Well, you could actually answer this one, something that I just said, without doing any math. Which one has a rate of change of 1/2 and a vertical intercept of 6? Yeah, one.
Because A is
Exactly. A will be a negative slope. So it has to be B. And actually the intercepts, the vertical intercepts are the same. So that doesn't help me. But and we can confirm it because if we go from this point to this point, we go up 1 to the right 2. That is 1/2. So it is B. Okay, last example. So this is kind of tying it all together. Here's how we can use these things. Okay. So we've got a graph that shows the cost of publishing a school yearbook for a school. So the independent variable, or the horizontal, is the number of yearbooks, and the vertical axis, or the dependent variable, is the cost. So obviously, you got to be able to read this graph. How much does it cost to publish 50 yearbooks? $1,500, because that's this one. Okay. How much does it cost to publish no yearbooks? Why do you think that is? Like, why do you still have to pay money and nothing was produced? Okay. Well, normally because they have to use equipment to produce it. And that equipment costs them money. So they're going to charge you money. It's like it's like that plumber example that we did. Okay. Charges $75 before he or she even does any work. It's the same kind of thing, except this is paying for equipment. Okay. So the cost of publishing, the budget for publishing costs is $4,200. What's the maximum number of books that can be printed? Well, that's really hard to read from the graph, because how do you locate 4,200? Like, it's going up by 500s. So like, it may be around here somewhere, a little less than half, because 4,250 would be halfway. And so if I go over to the imaginary line, I'm not going to be able to read it exactly. I mean, just by approximating, well, the number of yearbooks is going up by 25. So 150, then 175, and then maybe halfway to 200. So I don't know, 187 yearbooks or something, but I can't be sure. I can be in the area, but I want to be exact. So we can't use the graph to help us, which means we have to use algebra, which means we have to find the equation of this line, of this series of points. And how do we find the equation again? Remember, it's a derivative of the slope-intercept formula. Instead of y, it's dependent variable equals rate of change times the independent variable plus the initial amount. I've got most of this stuff already. I can just read it off the graph in front of the question. The dependent variable, well, that's the cost. What letter has been used to name the dependent variable? Sorry?
Oh, C.
C. Always look here, don't look here. C equals rate of change, which I actually have to calculate. What's the independent variable? What's the letter on the horizontal? N. What's the initial amount, as in when there's no yearbooks? How much does it cost? Right. So I've almost got the equation. I just have to find the rate of change. And we know how to find the rate of change. It is second y minus first y over second x minus first x. So let me just clear this up. So we can pick any 2 points we want. I'm just going to use these two, because those are pretty easy to read. This is the 0.05. This is the 0.50, 1,000. And then I'll just do this minus this, divide this minus this. What's wrong? It's not 1,000, it's 1,500. Thank you. Well, how you guys look at each other, but you don't get me. I'm the one who made the mistake. Good catch. 1,500 minus 500. Over 50 minus 0. So that gives us 1,000 divide 50. And we don't need the units for this one because we're just putting it into the equation. So that's going to give us 20. I mean, the units would be $20 per one yearbook. So now we can put that in there. And now we can use this to answer this question. So if the cost is 4,200, I'm going to use this. I plug 4,200 in here because that's, I'm told this is 4,200. And I'm trying to figure out the number of yearbooks n. So we've set ourselves up an equation. How do we solve it? Subtract 500 from both sides. So I get 3,700 equals 20n. And then divide both sides by 20. And that will give me my answer, which should work out to 185 yearbooks. So I was close when I used the graph, but not precise. So here's a good problem where you can use everything that we've learned to solve or to figure out some unknown. Okay. Okay. That is that.